Along the mighty Yangtze River in China stands a structure of unparalleled scale, the Three Gorges Dam. It's not merely a wall of concrete, but a testament to human ambition, a symbol of a nation's resolve to harness nature's immense power. Conceived from a vision spanning decades, this colossal project aimed to conquer the river's destructive floods, generate clean energy, and improve navigation across central China. But the journey to its completion was fraught with challenges, both engineering and ethical, leaving behind a legacy as monumental as its physical form. The idea of taming the Yangtze's power dates back over a century, a persistent dream to control its devastating floods that historically claimed millions of lives. Sun Yat-sen first proposed a dam in 1919, but it remained a distant aspiration. It wasn't until the late 20th century, with significant economic and technological advancements in China, that the vision began to solidify. This was more than just flood control, it was about powering a rapidly industrializing nation, linking its vast interior to the coast, and transforming a landscape. The scale envisioned was truly unprecedented. The chosen location, the Three Gorges region, presented both strategic advantages and immense challenges. This narrow, winding stretch of the Yangtze was ideal for concentrating the river's flow, providing a natural bottleneck for a massive barrier. However, it was also a region of deep valleys, treacherous currents, and complex geological formations, requiring exhaustive studies to ensure the dam's foundations could withstand the immense pressures. The decision to proceed here was a declaration of intent, signaling a direct confrontation with one of the world's most powerful rivers. Construction officially began in 1994, marking the start of a nearly two-decade-long endeavor. The first monumental task was to divert the Yangtze River itself. Engineers designed and built two enormous coffer dams, temporary barriers on either side of the main river channel, creating a dry construction pit in the middle. This Herculean effort involved moving staggering amounts of earth and rock, reshaping the riverbed to allow work to begin on the main dam structure. It was a race against the clock and the river's relentless flow, demonstrating the sheer scale of the initial commitment. Building the coffer dams was an engineering feat in itself, a testament to meticulous planning and execution. These structures, essential for drying out the central construction zone, were designed to withstand the Yangtze's immense seasonal floodwaters. They were constructed from millions of cubic meters of earth and rock, carefully engineered for stability and impermeability. This temporary infrastructure was crucial, as any failure would have catastrophic consequences, not only for the project's timeline but also for the safety of thousands of workers operating in the riverbed. Their success was foundational. Once the river was diverted, the true scale of the dam's physical construction became apparent. The Three Gorges Dam is a gravity dam, meaning its sheer weight holds back the water. This required an unprecedented amount of material. Over 27 million cubic meters of concrete were poured, along with hundreds of thousands of tons of steel. To put that into perspective, it's enough concrete to build 400 pyramids the size of Giza's Great Pyramid. This continuous, enormous pour, often under immense pressure, pushed the boundaries of modern construction techniques and logistical coordination. One of the primary engineering challenges was the Yangtze River itself. Known for its powerful currents and dramatic seasonal floods, the river posed a constant threat. Construction had to be meticulously timed around flood seasons, and emergency measures were always in place. The sheer volume of water, especially during peak flow, meant that any breach or miscalculation could have catastrophic consequences, sweeping away equipment and endangering lives. Engineers had to design structures and processes robust enough to withstand not just the eventual reservoir, but the river's dynamic force during construction. Beneath the surface, another critical challenge was the geological stability of the dam site. The Three Gorges region is not entirely tectonically inert. Extensive seismic surveys and geological studies were imperative to ensure the bedrock could support the immense weight of the dam and the pressure of the 39.3 billion cubic meter reservoir it would create. Engineers had to grapple with fault lines and rock formations, employing advanced stabilization techniques to guarantee the long-term integrity of the structure. The safety and longevity of the dam depended entirely on its immovable foundation. Behind the concrete and steel were hundreds of thousands of workers. At its peak, the project employed an estimated 250,000 people directly, with countless more in supporting industries. These men and women, often from rural areas, lived and toiled under arduous conditions, pushing the limits of human endurance. Their collective effort, day and night, year after year, was the true engine of construction. It was a logistical marvel to house, feed, and manage such a massive workforce, coordinating tasks across a colossal, dynamic construction zone, a testament to human organization and willpower. The most profound and controversial cost of the Three Gorges Dam was the forced relocation of over 1.3 million people. As the reservoir filled, ancient villages, towns, and even entire cities were submerged beneath the rising waters. Families, many of whom had lived in the region for generations, were uprooted, often moved to newly built settlements on higher ground or to distant provinces. This displacement led to immense social disruption, loss of ancestral homes, and cultural heritage, a stark reminder that progress often comes at a significant human price, measured in lives, not just dollars. Beyond individual homes, the rising waters also claim thousands of archaeological sites and cultural relics. Centuries of history, from ancient burial grounds to temples and historical structures, were swallowed by the reservoir. While rescue archaeology efforts were undertaken, the sheer scale of the inundation meant that much was lost forever. This cultural sacrifice represents an irreversible loss of tangible heritage, changing the historical landscape of the Yangtze River Basin permanently. The dam not only reshaped the physical environment but also severed deep historical connections. Financing such an enormous undertaking was a complex web of government investment, domestic bonds, and international loans. The official final cost of the Three Gorges Dam project was approximately $28 billion. However, various independent estimates place the true cost significantly higher, potentially exceeding $70 billion when all associated expenses, including relocation, environmental mitigation, and interest on loans, are factored in. This massive expenditure represents one of the largest single infrastructure investments in human history, highlighting the economic burden of such ambition. Completed in 2006, main dam structure, and fully operational by 2012, the dam's primary function shifted to power generation. With 34 generators, it became the world's largest power station by installed capacity. This massive output supplies electricity to vast areas of central and eastern China, significantly contributing to the nation's energy security and reducing its reliance on fossil fuels. Beyond power, the dam includes a sophisticated system of ship locks, dramatically improving navigation along the Yangtze, allowing large vessels to travel much further inland than ever before, stimulating regional trade and development. While providing benefits, the dam's environmental footprint is extensive. One significant concern is sedimentation. The dam traps vast amounts of sediment, preventing it from flowing downstream. This has a dual effect. The reservoir itself gradually silts up, reducing its capacity over time, and the downstream regions are deprived of essential silt that naturally fertilizes agricultural land and replenishes riverbanks. This change in the river's natural sediment cycle can lead to increased erosion downstream and impact the delicate ecosystem of the Yangtze River Delta, a fertile and densely populated area. The creation of the reservoir transformed a flowing river into a vast, stagnant lake, profoundly altering the aquatic ecosystem. This change threatened numerous endemic species, including the critically endangered Yangtze finless porpoise and the now extinct Baiji dolphin. Their natural habitats were disrupted, migratory routes blocked, and food sources altered. The shift in water temperature and quality also impacted fish populations and the delicate balance of the river's biodiversity, representing a significant loss for a region known for its unique flora and fauna. Another serious environmental concern is pollution. Before the dam, the river's flow helped disperse pollutants. Now, the slower-moving reservoir allows them to concentrate, impacting water quality. Furthermore, the immense weight of the reservoir's water has been linked to an increase in localized seismic activity and landslides along its banks. While these tremors are generally small, they raise concerns about long-term geological stability, especially given the dam's proximity to active fault lines. the long-term consequences of these effects are still being monitored and studied. Despite its criticisms, the Three Gorges Dam has undeniably achieved its primary goal: flood control. The Yangtze River Basin, historically prone to catastrophic floods, has seen a dramatic reduction in major flood events since the dam's completion. The reservoir's capacity allows engineers to regulate water flow, holding back floodwaters during heavy rainfall and releasing them gradually. This has protected millions of people and billions of dollars in agricultural land and infrastructure downstream, fulfilling a centuries-old aspiration and saving countless lives, a significant benefit often weighed against its costs. The Three Gorges Dam stands as a monumental achievement of engineering, a powerful symbol of human capability to reshape nature. Its construction pushed the boundaries of technology and logistics, delivered immense clean energy, and provided crucial flood protection. Yet, these triumphs are inextricably linked to profound human and environmental costs. The displacement of over 1 million people, the loss of cultural heritage, and ongoing ecological challenges present a complex legacy. It forces us to confront the intricate balance between progress, resource management, and the preservation of natural and human ecosystems.